For example, if you're asked to find the point of intersection of this pair of lines, 2x square minus xy minus y square plus 9x minus 3y plus 10 is equal to 0. So in the question, it is given that this is a pair of lines and you're asked to find the point of intersection. So the process is very simple. First, differentiate this expression partially with respect to x. That is, take y as a constant. So 2x square differentiation becomes 4x minus xy's differentiation becomes minus y. This differentiation becomes 0 plus 9 is equal to 0. And let us partially differentiate this with respect to y now. So you get minus x minus 2y minus 3 is equal to 0. Now you need to solve these two to get the point of intersection. So I'll multiply this with 4. So if you add these two, 4x minus 4x gets cancelled. Minus y minus 8y is minus 9y. 9 minus 12 is minus 3 is equal to 0. So 9y is equal to minus 3. So y is equal to minus 1 by 3. Y is equal to minus 1 by 3. And once you put y is equal to minus 1 by 3 here, so 4x plus 1 by 3 plus 9 is equal to 0. So 12x plus 28 is equal to 0. This implies x is equal to minus of 14 by 6 or minus 7 by 3. So the point of intersection is nothing but minus 7 by 3 comma minus 1 by 3. So this is the point of intersection of these two lines. But the important thing that you need to understand is, by solving these two line equations, you are getting the point of intersection. But don't get confused that these represent the lines that make this equation. No. If you factorize this, you get some other lines. These are not the lines which make up this equation. Please keep this in mind. If you are asked to find the individual equations which make up this line, you cannot do partial differentiation and get the answers. This method is only useful in finding the point of intersection. There is no relation with these lines with the lines that make this pair of lines. So do the partial differentiation, solve them, you get the point of intersection. That's it. So partial differentiation will not be useful in factorization of this pair of lines. Thank you.